Assalamualaikum. Before I start, allow me to introduce myself. My name is Nizam bin Indrawaty from Universiti Teknikal Malaysia, Melaka. I'm here to present my project with the title Assessment on Potential Energy Storage Technologies for a Rail Transportation System. And the first part is project description. Supercapacitor used as energy storage system to capture regenerative energy produced by linear induction motor of urban rail transportation during braking. And for this project, I have three objectives. The first one is to identify the way in which regenerative energy recovered by using a supercapacitor in Malaysia's urban rail transportation system. And the second one is to analyze the charging and discharging behavior of the supercapacitor during regenerative braking using simulation software. And the final objective is to evaluate the appropriate size of the energy storage system for the urban rail transportation system in Malaysia. And for the next is problem statement. According to the Energy Commission, the urban rail transportation system in Malaysia consumes a lot of energy to operate. While consume energy, urban rail transportation able to generate energy. The generated energy will be wasted if not used entirely. And for the methodology, I start with preliminary research work, which is to review the previous literature. And the next part is ESS configuration, which is to determine whether to use onboard energy storage system or bedside energy storage system. The next part is ESS design, which is to design a single cell supercapacitor by referring to XL60 supercapacitor by UTeM. And the next one is ESS size. For this part, I will design several supercapacitor modeling, which are small size energy storage system, medium size energy storage system, and large size energy storage system. And the next part is result analysis and discussion. For this part, I will analyze all the modeling and doing the calculation. And the last part is final documentation, which is all of this will be documented. And the next part is result and discussion. As you can see here, I'm including one of the modeling, which is small size energy storage system. At the top here is the modeling by using Plex software, and the bottom here is the output for the simulation, which show the voltage and current during charging and discharging. And for the conclusion, out of three energy storage system modeling, small size ESS is the most suitable due to the less cost and more efficient than the other two models. And for project features, by using Plex software, the energy storage system can be designed and set the parameter of supercapacitor to obtain the result. And for the project potential of commercialization, ESS is crucial in urban rail transportation for energy recuperation, voltage stabilization, emergency supply, and reduce peak demand. And here are some reference for this project. And the next is I will demonstrate for the simulation. This is the single cell supercapacitor modeling, and as you can see here, this is charge and discharge controller to control the simulation, and this is the scope to obtain the output result, and this is the supercapacitor. For charge and discharge controller, the parameter has been set with charge current 2400 ampere, discharge current negative 2400 ampere, charge start time at 2.5 seconds, maximum discharge time 2.5 seconds, maximum charge time 10 seconds, minimum voltage 0 volt, maximum voltage 3 volt. And start with this simulation. This is the output obtained from the simulation for charging and discharging. And here the current able to fully charge at 5.4 seconds and able to fully discharge at 14.8 seconds. And this is the voltage when charging, and this is the voltage when discharging. This is small size energy storage system modeling. This modeling has been designed based on single cell supercapacitor, and as you can see here, this unit represent 250 unit supercapacitor in series with 12 string connected. And to design for the bigger system, the supercapacitor need to be connected in series to obtain the rated voltage, and to increase the power, the supercapacitor need to connected in parallel. And for charge and discharge controller parameter, the charge current is 4000 ampere and discharge current negative 4000 ampere. Charge start time at 2 seconds, maximum discharge time 8 seconds, maximum charge time 8 seconds, minimum voltage 0 volt, maximum voltage 750 volt. And for the supercapacitor parameters, rated voltage 750 volt, V initial 700 volt, DC capacitor 12 volt, voltage dependent capacitor 1.2, DC resistance 0.0575 ohm, and leakage current 1.75 ampere. And for the simulation, so this is the result obtained from the simulation for charging and discharging. The current able to fully charge at 10 seconds and able to fully discharge at 18 seconds. And this is the voltage when charging, and this is the voltage when discharging. This is medium size energy storage system modeling. Basically this modeling is the same with small size energy storage system modeling. The only difference is the string is 33. And for charge and discharge controller parameter, charge current 4000 ampere, discharge current negative 4000 ampere, charge start time 2 seconds, maximum discharge time 24 seconds, maximum charge time 24 seconds, minimum voltage 0 volt, maximum voltage 750 volt. And for the simulation, so this is the simulation obtained for the simulation charging and discharge, and the current able to fully charge at 26 seconds and fully discharge at 50 seconds. And this is the voltage when charging, and this is the voltage when discharging. So this is the last modeling, which is large energy storage system modeling, and this model increase the number of string up to 54 string. And for charge and discharge controller parameter, charge current 4000 ampere, discharge current negative 4000 ampere, charge start time at 2 seconds, maximum discharge time 40 seconds, maximum charge time 40 seconds, minimum voltage 0 volt, maximum voltage 750 volt. And for the simulation, so this is the simulation obtained for charging and discharging. The current able to fully charge at 42 seconds and fully discharge at 82 seconds. So this is the voltage when charging, and this is the voltage when discharging. That's all for me. Thank you.